Hi, I'm Jordan. We are Artisan Electrics and this is how to install a MyEnergi Libbi battery. So MyEnergi reached out to us and asked if we could create a step-by-step video to help installers know how to install a Libbi in the real world. And it's our privilege to do that today. So in this video, we're going to show you step by step, following the instructions, but in the real world, how to install a Libbi. Now, before we start, a couple of disclaimers. Number one, we are installing the Libbi according to the instruction manual today on the 29th of June 2023. The instructions could evolve over time, so make sure you check the manufacturer's instructions up to date when you're installing it. Number two, this is only for professional approved installers. This product cannot be installed by a DIYer. In fact, to register the warranty, you have to be an approved installer with MyEnergi and have to have done the training already. So without further ado, let's get into it. For our regular viewers, you might recognise this property. We were here last year fitting the solar on this roof. We've done a whole series of videos here from start to finish showing how to install solar. So if you'd like to watch more about solar and the prep work that we did here, there's a link in the description. Let's get the Libbi in and unbox it. Oh man, that's the number one. Make sure you work out regularly if you're going to be installing these. So we're installing the Libbi here just as purely an AC coupled battery system. So the hybrid inverter on top of the Libbi is just purely doing discharge and charge of the battery. That's because we've got an existing solar edge solar inverter here, which is doing the generation from the solar panels. Later on in the video, I'll show you how to connect the solar panels directly into the Libbi. We've done that on a different project, so we'll go over there in a bit. But right now, we're going to do step by step on how to use the Libbi as an AC coupled battery system. So basically, there's loads of safety things in the introduction of the manual. Make sure you read the safety warnings before you go about installing one of these. So let's get everything unboxed and show you all of the system components. So this is the hybrid inverter. It comes in two sizes, 5 kilowatt and 3.6 kilowatt. We've chosen the 5 kilowatt for this system because we've got 8 kilowatts of solar and the customer wants to be able to charge and discharge the batteries on the cheap electricity overnight as well as an option in winter when he's not generating enough solar to fill the battery up fully. So the inverter comes with a pack of various bits and pieces. Let me show you what's inside. So this is the AC cable connector. This is the backup cable connector. These are for if you're installing solar PV strings directly into the inverter, but that's also got the fixings inside. So you've got 2 male and 2 female MC4 connectors for the DC strings. Then you've got 2 screws and 2 plugs for fixing the inverter. These are the pins for inside the MC4 connectors. These screws are important, you'll need those, and this tool is also useful for disconnecting the MC4 connectors later if you need to. So as we're not connecting solar to this particular inverter, we're going to just save these MC4 connectors and bits, put them back in the packet. Maybe later the customer might want to add more solar to it, you never know, so it's always good to keep these to hand and leave them with the customer on site. These two connectors are not actually needed because the RS485 connector is already provided with the Libbi controller. So this is the Libbi Controller, which is the brain of the system and integrates it to the MyEnergi ecosystem. Let me show you. So this is the RS485 cable. This end plugs into the inverter and this end connects into the Libbi controller so that the inverter and Libbi controller can talk to each other. So the last thing in the box is the CT clamp here and 2 aerials, which are very important for the Libbi controller to communicate via Wi-Fi and its own internal signal. In these boxes we've got the battery modules. Let me show you. Now, as you probably saw when we were lifting these in, they are super heavy, over 60 kilos each. So it's definitely a 2-man lift for safety, and you don't want to drop these because that could cause a problem. Each of these battery modules is 5 kilowatt hours and you can stack up to 4 batteries on one inverter in 2 stacks. So you can have the inverter and 2 batteries adding up to 10 kilowatt hours. then you can have another stack of 2 batteries next to it for a total of 20 kilowatt hours, which is what we're going to do here. That's the maximum size system that you can have on one phase. So these are the floor stands. Now we're going to be fitting these as standard just to keep the batteries slightly raised up off the floor. They aren't absolutely essential, because if you've got a very nice flat floor that's easy and level, you can just mount the batteries directly on the floor. However, I like to install these for 2 reasons. One, if you've got an uneven floor, these little feet are adjustable, so it enables you to get the floor stand level and then stack everything up from there. And also, it just means that everything's slightly raised off the floor, which can be helpful. You know, imagine if there's a bit of flooding or something like that. It just raises the batteries off the floor slightly, which I think makes everything a little bit safer. Now, one thing I've seen and we nearly forgot once is the top cover for when you're doing 2 stacks of batteries. Obviously, the normal 10 kilowatt hour kit, you've got the Libbi inverter at the top, so you don't need a top cover for that top battery. But if you've got a second stack of batteries, you need an additional top cover to just neatly finish off the top of that second stack of batteries. That's what this is. I've seen some people installing them without, and it's doable, but it just looks really ugly. So definitely add a top cover to your order if you're ordering more than 10 kilowatt hours worth of batteries. Another sneaky tip about the floor stands, which I probably shouldn't tell you as this video is sponsored by MyEnergi, but at the time of filming this, MyEnergi haven't actually released their own floor stands yet, but the floor stand is identical to the SolarEdge one, because SolarEdge are also using the CATL batteries, which are the same batteries as in the MyEnergi system. So you can order and use the SolarEdge floor stands for the SolarEdge 48 volt batteries, I think they're called, something like that, and they're a perfect fit. So if you can't get a MyEnergi one, you can get a SolarEdge one. It might get you out of trouble. Now, for each different setup of the Libbi, you've got different cable packs that you need in order to connect the different battery modules. We've ordered a 10 kilowatt hour kit, and then we've added 2 extra battery modules, which is a bit of a mistake because they send you the 10 kilowatt hour battery cable pack with the 10 kilowatt hour kit, but we can't use it. So actually that's spare, and we've had to order a separate 20 kilowatt hour battery kit, which is the EK201, which has the longer leads to connect between the 2 towers of batteries. So a little top tip I would say for you is only order the parts individually that you need. That way you're not going to end up with loads of leftover cable kits that you can't use. It's better for the environment and it'll save you a few quid. This is inside the cable pack. You've got various red and black cables to connect between the different battery modules, and all the cables are pre-terminated with the ends, and they're all the right lengths based on the number of battery modules that you've got. You've got the earth cables as well to connect between each module to bond everything, and then you've got these communications cables which allow the battery modules to talk to each other and see the state of charges and all talk back to the inverter. Now I'm going to talk you through all the system components here of the existing system so that you know how those link with the MyEnergi Libbi system. And as I said earlier, if you want to watch the full install of this and see how we installed it all in detail, including the panels on the roof, there is a link below to a whole series of videos that you can watch that we filmed here. But basically this is the SolarEdge inverter that we've got. Now you might wonder, why have we fitted a SolarEdge inverter? Why did we not use a Libbi inverter to plug the panels straight into? Surely that would save money and be more efficient because you can take the DC straight into the Libbi. The thing is that we've got 32 panels on this roof, over 10 kilowatts of panels, and the maximum amount of solar panels that you can connect to the Libbi inverter is about 6 kilowatts, 3.25 kilowatts per string, and you can have 2 strings. So we would never have been able to connect all of these into the Libbi, which would mean that we'd have to either fit less panels or use an alternative system, which is what we've done. The customer's house, they use a lot of power, so they needed to have the maximum output possible. Also, this is an east-west facing array with some shading, so SolarEdge is good for that because you can optimize all the panels. That being said, if you do have a very simple solar setup that's less than 6 kilowatts of panels, you can connect those panels directly into the Libbi and avoid having a second separate inverter, which will save you a bit on cost and make the system a little bit more efficient. So in this system we've got a consumer unit with various circuits. So we need 2 circuits for the Libbi system ideally. 1 circuit for the actual inverter. That is usually a 32 amp circuit breaker for a 5 kilowatt inverter, or 16 or 20 amp breaker for the 3.68 kilowatt inverter. Then you need another circuit for the Libbi controller. That needs to be run off a 3 amp fused connection unit. So you can either run it off an existing socket circuit or just run in a separate radial, which is what we have done. We run in a separate radial for this socket here and the supply for the SolarEdge Modbus anyway. So we're going to just loop out of that and install an additional fuse connection unit for the Libbi controller. The other things that we've got here are, we've got a hardwired Ethernet. So because we're remote from the house, we ran a data cable from the router in the house to here. We've got hardwired Ethernet, so we're going to hardwire everything. However, you can connect the Libbi controller via Wi-Fi, and it will work as long as you've got good Wi-Fi signal. Other things that we've got in this system: DC surge protection for the strings of the solar panels on the roof, 2 DC isolators, 1 for each string. We've got a little junction box here for all our CT connections. We've got a Zappi, which is existing, and we're going to get that firmware updated in a minute so that it'll talk well to the Libbi. This is our SolarEdge inverter and Modbus. We've got a generation meter and an AC isolator to isolate the SolarEdge inverter there. And then we've got an additional AC isolator, which we've already installed, ready in preparation for connecting the Libbi to. So that is run off its own circuit in the consumer unit. All we need to do now is connect the AC flex cable from this into the Libbi. That will power it up. We've also got backup power here, so I'll talk to you about how that works a bit later. But first, before we get too carried away, let's get everything updated with the firmware on the existing devices. That can be running then in the background, and it saves us a bit of time later. So one of the first things I do when I get to site is update the firmware on the existing MyEnergi devices. To do that, you go to the menu, you go to other settings, download firmware, check for updates, and it will request to see if there are any updates available. It says idle and it says status up to date. So if I go to the information menu, I can see what version of firmware. So the customer has already updated the firmware to version 5.048, which is great. That's important because version 5 is the version that they've released since they released the Libbi. If you have version 4 or earlier, the other devices won't know what a Libbi is, and then they won't be able to talk to it. Little tip about this: there's a heck of a lot of packaging with these. So when you're planning these jobs, you need to make sure that you've got enough room to take away the packaging. If you, as an installer, in your customer terms and conditions say that you will dispose of the rubbish, you need to have plenty of space to get rid of that, and you need to allow some time to dispose of it responsibly. Or you need to have an agreement with the customer that they will get rid of the packaging, because there is probably a whole van's worth of packaging in here. We have these delivered to site by our wholesaler. There's an important reason for that. In the installation manual, it says that if you're transporting them, you need to have an ABC fire extinguisher with you. Remember, these are lithium batteries. If they catch fire, they don't go out very easily. So we've chosen to not transport them ourselves, but to get our wholesaler, who are prepared and equipped to deliver them safely, to deliver them straight to site for us. But if you're choosing to, say, get a load delivered to your unit or something and then take them out yourself to site in your vans, you need to make sure you've got an ABC fire extinguisher to hand. Now, I've got a confession to make. We did make a little mistake when we did the install here originally, which is that we put the Libbi circuit on an RCBO, and we also put the SolarEdge inverter on an RCBO. We later found out that Fusebox RCBOs are not bidirectional, which means that they can't feed power back through them into the system. It works, but what happens apparently is if you press the test button while it's feeding power back into the system, it won't work properly. So we're going to swap these out for MCBs. The fact is that SolarEdge inverter doesn't need RCD protection unless the cable supplying it does. Same with the Libbi inverter, it doesn't need RCD protection if the cable is run in trunking or something like that, and it doesn't need RCD protection for the cable. So we're going to put them on MCBs instead of RCBOs. So on our existing solar circuit here, we've got a solar CT. This is for the MyEnergi system to read how much solar is being generated and just for you to be able to gather the data about your generation. You can get away without a solar CT with the MyEnergi system, and it will just read import and export with the grid CT. However, we always like to add that additional CT just to gather that data. Here, the customer's actually got 2 solar arrays as well. They've got the one here on the garage, but they've also got a smaller one in the house that's from about 10 years ago. And we've got both of them in the MyEnergi system so we can see how much each of the solar arrays is using. If you're connecting the solar PV directly into the Libbi inverter, you do not need a solar CT because the Libbi controller reads how much solar is being generated through the hybrid inverter. So that's a little thing to note. If you do add a separate solar CT onto the Libbi circuit, it gets confused and it shows 2 solar arrays when there's only one. So don't install a solar CT if you're connecting the solar directly into the Libbi. So we're going to get all the battery modules mounted on the wall now and the inverter, get the floor stand leveled, stack everything up, and then we can connect everything after. If you want to recycle some trees, it's always good to have a bit of backer wood sometimes for various occasions. So we just keep these on the van, sometimes they come in handy. So there are 8 different configurations that you can have. The 3.68 kilowatt inverter with 1 battery module, 5 kilowatt hour, or with 2, 3 or 4. So these just give you an idea of the different configurations, and then the same for the 5 kilowatt inverter. You can have 1, 2, 3 or 4 battery modules. This is the setup that we're going for here, so you'll get to see that in the real world as we install it. A little note here too, the Libbi is not compatible with Zappi version 1. That's the really old original Zappi. Not many people still have those, but if you do, just note it's not compatible with the Libbi. So first things first, we're going to get the floor stand into place and level where the first stack is going to go, where the inverter is going to go. So we've laid this fireproof hardy backer board on the wall. We usually do this, just it adds a fireproof backing to any wall that we're mounting on, and it gives us a nice smooth surface to mount to. You don't necessarily need to, but it's a nice touch that we tend to do just to make everything look neat. Now I've lined my laser up with the edge of the hardy backer so that I can see where the edge of the Libbi is going to go, and then I'm lining up the stand to make sure that the edge of the Libbi will line up with that laser line. Then once the stand is spaced out correctly from the wall, we can put a level on it. Now you can see it's slightly high at the back there, so what we want to do is just adjust these legs so that the back lowers down slightly. From side to side we're absolutely bob on, so it's level that way. We just need to lower the back a little bit. So to raise and lower the legs, you turn the flathead screw on the top side of the stand. That will lower this leg or raise this leg. So actually what we need to do, rather than lowering the back, because we can't lower the back anymore, is just raise the front slightly and then lock those into place with a locking nut. So the floor stand's all level. We need to get the first battery module on and then sit that against the wall just to make sure it all fits correctly. In order to do that, we've got to attach the wall mounting bracket to the battery module. So each battery module comes with 4 fixing screws, 4 raw plugs, and 2 screws like this, which are to fix this bracket down. They also come with 4 washers for the fixing screws. So we'll connect this on loosely so that can be slid back to match the wall level. So in order to fix this back, we need to remove this handle. The handle will need to go back on again afterwards. Right, 1, 2, 3, up.
It's got to come over. I've got about 1 inch.
What, towards you?
Yeah. Okay. It should sit. That's it.
Now there's a nice little feature that these floor stands have these little bumps, and the bumps fit into the bottom of the battery module, so it kind of lines up and you know that it's fitting securely in the right place. So you can just feel it when it clicks into place, you know that you're good. So now that this is provisionally in place, we're just going to double check that it is level, which it is. That's perfect. Now we're going to mark the holes here. We're going to use the 2 top middle ones and then the 2 bottom outside ones. And then what we're going to do is detach this, drill the holes with a cover over this so that we don't get any dust on it. Then we can fit the bracket back, screw everything in, and we'll need to take this handle off in order to get the screws in properly. So we use a 10mm drill bit to drill the fixing holes. That is for the raw plugs that are supplied by MyEnergi and are designed for this. Make sure you wear safety glasses and ear defenders if you're drilling. So just to avoid it slipping out of place and then you're not being able to line these up, I'm just putting these grub screws back in now. Now that we've got the bracket secured roughly with one, put the grub screws back, and then you can fix the rest of the wall fixings back. So now we're going to put the handle back and then lift the next battery module on top. So we've got our second battery module just resting on the top one. We do the same with this, fix it back to the wall. However, because the inverter's on top of this one, we're only going to fix these 2 back at the moment because the bracket for the inverter is going to go on top of here and line up with that. And then the screws for these 2 will go through the inverter bracket and the battery bracket. But first, we're just going to need to cut this back a little bit because we just overran it. We just used the full length. We'll cut that back to the right size and then we can mount the inverter on top. I get to use this bad boy. This is our new Hilti multi-tool, which is an absolute beast. So this is the inverter bracket. And as I said, that mounts over those 2 holes there using the same fixings. So what we're going to do is just get this leveled up and then mark these fixings as well. And then we can drill them all at the same time. So what we just found is that the bottom battery was not quite level this way, and so now this top module was even more out. So what we've done is we've just taken this one off, we've made sure that the bottom battery was level from front to back, and then these are easily adjustable, so you loosen these screws, you can pull them towards you or towards the wall just to get them level, so that this is now level vertically as well, and that just means that the inverter will be, and everything's stacked perfectly from side to side but also from front to back. So now the 2 screws that come with the inverter don't have washers with them, so we'll put those in the bottom because these holes don't need washers. So those will go in there. Just get them finger tight to start with. Those 2 are finger tight, and then we can put the ones with the washers in the top. And we get a level on this and just give it a little bit of an adjustment until it's perfectly level. Then final tighten. So this is the back of the inverter, and this hook here slides into that bracket that we've just mounted on the wall to hold the inverter in place. So because we've got plasterboard up here, we've decided to use these anchors just because the plugs and screws that we were using from MyEnergi just didn't quite cut it in plasterboard. You need a really good solid fixing. You don't want it to pull off the wall. So these are hollow wall plugs. I don't know exactly what they're called. I'll leave a link in the description where you can get these. That goes onto this tool like that, and then it pulls, and this opens up in the wall, and so it grips to the plasterboard like that, and then there's no way you're getting that out. It's a really, really solid fixing. So for situations like this where you need to mount something very heavy to a plasterboard wall, this is probably the way forward. So now that the inverter's hooked onto its bracket, we're going to undo these thumb screws, which you can do by hand usually. Just lift the cover off, and then there's a couple of grub screws to fix it back to the bracket. So the inverter, once it's on its bracket, needs to be secured to the bottom, the battery, by these grub screws. So it's almost a two-man job really, just to pull that slightly towards us, and then this one, yeah, that's it. Line it up, and then
that was undersized.
so we're going to mount the second stack of batteries now. It's exactly the same as the first stack, kind of rinse and repeat, get it all level, stack them up, and then we'll get the top cover on. So that's the second stack done. Now we need to put the top cover on. So obviously, you know, you could do it without the top cover, but it just looked pretty hideous. This top cover just allows everything to be neatly finished. Just goes on like that, and it's a nice chef's kiss finishing touch to the whole thing. So it lines up like that, and then you got 5 screws to put in down here. So the top cover goes on with these screws. Right, so in terms of how far to space these stacks apart, there is a little bit of flexibility on it. However, I've seen some keyboard warriors saying, oh, you need to have them 600mm apart because the instructions say that it should be spaced 600mm from any other devices. Well, that's impossible because the cable packs won't reach between them if you do them that far apart. However, I would suggest that you space them a little bit far apart enough to get the flap open there. Otherwise, you're going to cause yourself a problem later. So about 200mm, maybe 300mm between is fine. I would probably do it slightly further apart than this in future, just so that you can get a normal length screwdriver in. Now I'm going to have to use a dumpy screwdriver, but it's not the end of the world. So yeah, about 300 between or 200 between should be fine. So now that we've got the batteries mounted, we're going to mount the Libbi controller and then start wiring everything up. Our Libbi controller will go nicely there. So the Libbi controller needs to be mounted indoors. It can't be mounted outdoors because it's not weatherproof. The Libbi equipment can be mounted outdoors if you have to, but I would always recommend inside if possible. Other thing about this, it's got these grommets in the bottom. You've got various cables that need to go into this. You've got power, so you'll need to feed it from a 3-amp fuse connection unit. Then you've got 3 CT connections that can go into it. And you've got the RS485 cable which plugs into the battery. So what I'm going to do is just cut out a couple of these knockouts like that. And then we're going to put it on top here so it's easily visible and accessible next to the Libbi. And then we're going to mark the holes here, drill a couple of holes to bring the cable through the trunking. So I'm going to mark the fixing holes here as well. 3 fixings, 1 at the top and 2 at the bottom, and then we'll mark these holes here to bring the cables through. So now as we're about to start working in the consumer unit, we need to make sure everything's safely isolated. So we're going to just turn off all the circuit breakers in here for the moment, and then turn off the main switch, and then we'll just do a test to make sure it's all dead. Whenever you're working on electrics, always make sure you isolate safely, and if there's other people around, lock out, tag out as well. So for running the power to our Libbi controller, we're going to run it off this socket circuit that we've already run in. There's only 1 cable going into that at the moment, and it's just on a 16-amp MCB. So we might as well just do that, and then it'll be easy to run the cable over to our switch fuse connection unit for our Libbi controller. So we mounted a back box for our switch fuse connection unit to power the Libbi. Then what we've done is mounted 2 double sockets as well. These are going to be fed from a backup board, which will be running off the Libbi, which will be constantly live, but in the event of a power cut, those 2 sockets will stay live so that the customer's got emergency power just to run a few essential things if they do have a power cut. Now it is EPS, not UPS, which means that it does skip a cycle or a half cycle in the sine wave, so it's not necessarily going to be instantaneous, but is pretty quick, to be honest. So it's good for backup power in an emergency, but if you need UPS, which is completely uninterrupted power supply, like for very essential computer equipment and stuff like that, you shouldn't necessarily be using the backup side of the Libbi for that. So this is the feed cable that goes into the Libbi to power the Libbi from the AC isolator. Now it is important that you have a proper isolation switch, double pole isolation. For this we've used a 63 amp isolator, but a 32 amp isolator will be fine basically, as long as it's rated at the same as the circuit breaker or higher. Lee's just wired the AC plug onto the cable, and we're just going to thread it through now into our trunking, up into our AC isolator here. And then just going to strip that back, put some ferrules on the end because it's fine stranded cable, and then wire that in. Lee's now wiring up the backup plug, which is a slightly different plug, but the same principle. So we strip this back, and now I'm going to put the ferrules on, crimp them on neatly. That just holds all the fine strands together so they don't splay out. Usually give a couple of crimps on each one, and then we can connect that into the isolator. So this inverter, like most solar inverters to be honest, is called a grid-tied inverter. It means that it needs a grid connection in order to function. So if you lose power from the grid, say there's a power cut, the inverter will stop. That means the solar panels won't be generating power and feeding it back into your system. That's just the way it is for safety, because imagine if they purposefully isolated the cables outside your house in the road because they were working on them. Imagine if then your solar was generating still and pushing power back down those panels, somebody could get electrocuted. So it's a safety reason that they have this grid-tied feature. However, the backup circuits come out of the other side of the inverter. So the inverter is not feeding back through the main circuits, but it's only feeding back into this backup terminal. And it has like an internal changeover switch that does that. So if the Libbi controller was the only device on the system, if we didn't already have a Zappi and an Eddy, we would connect this CT into one of these CT terminals. Now they provide you with one CT, and the mandatory CT that you need is the grid CT. So we would hardwire the grid CT into here, and then if we had a separate solar CT, we'd have to purchase an additional CT to go into CT2 for the solar. And because we've got CTs already in place for the grid and the solar connected to the Zappi, we don't need to do that. So we're going to just wire in this RS485 cable from the battery into the Libbi controller. So this little plug will plug into the COM terminal, and you just got to line that little notch up so that it plugs in like that, and then screw it home. Now this RS485 cable that they provide is 1, 2, 3, 4, about 5 meters long. So you've got ideally to fit the Libbi controller within 5 meters of the Libbi inverter. However, if you do need to put it further away, you can extend this with a normal twisted pair cable like a Cat 5 or a Cat 6. So I'm going to connect these two into the RS485 terminal there, A and B. Now which wire goes in A and which wire goes in B? Let me know your guesses in the comments below. So well done to those of you who got it right in the comments. Red is A and black is B. And we'll just put a little ferrule on there just to neaten that up. Push that in like that, and then pop that in the terminal, and the same with the black one. And you need to just peel this screen protector off as well. There's a little bit of a knack to getting this cover on, so you slide it from below like that. Just be careful not to get those aerial cables, and then that'll slide up and click in like that, and there's a couple of little lugs at the top that just hold it in place, and then the little screw at the bottom to secure it in place. So we've installed this backup consumer unit here, wired off the backup terminal of the Libbi. Now there's a few rules about backup power that you need to be careful of. The backup circuits must be protected by type A RCD. So that's what we've done, type A RCD here with an MCB. Now in this case we're only running 2 double sockets off the backup circuit. They're just there as emergency power supply in case of a loss of power from the grid, that the customer's still got a couple of sockets that they can use. Another important rule, you must have an alternative means of earthing. So we've installed an earth electrode, connected that to the main earthing terminal of the property, so that if the PME earth is lost, we've still got a good earth that this system can run off of. All of this is running off a 32 amp breaker here in the inverter. You can see that is the backup circuit breaker. However, just because it's on a 32 amp breaker doesn't mean that that's the maximum amount of power that you can run on backup. There are 2 options. With a 5 kilowatt inverter, you can run a maximum of 20 amps off of the backup circuits. With the 3.68 kilowatt inverter, you can run a maximum of 16 amps off the backup circuits. And there's one more important consideration. When you're designing the install, remember that if you're running backup power, you need to size the supply to the input side, to the grid side of the inverter, suitably that it can cope with the inverter load plus the backup loads. So for example, if you're running a 3.68 kilowatt inverter with 3.68 kilowatts of loads, backup loads for argument's sake, you would need to size the supply cable that it could cope with 7.36 kilowatts of power at any one time, because the inverter could be pulling and charging the batteries, but also the backup loads will still be running. So that feed cable that's supplying the Libbi inverter will be running at more than just the rating of the inverter. It will have the backup loads running through it as well. So unfortunately this metal clad spur that we were going to fit has failed. The terminals are broken, so we're going to put a plastic one on temporarily just to get it livened up, and then the guys are going to come over and bring us a replacement metal one. So now it's time to connect the battery cables. First, the power cables between the batteries. So this negative cable is going to go from the inverter, battery negative, push that until it clicks, and then that's going to go into the top battery negative of the top battery. The plugs need to be standing straight in order to go in, and then they click, and give them a little tug to make sure that they're clicked in properly. To unplug them, if you need to, there's a little button in the side, you can push that and then pull them out like that. So we're going to do all the blacks first. So then we go from this battery to this battery. In fact, we'll just unplug all of the battery leads, plugs here, so that they're all done. Keep the bungs to one side, just in case. And then plug that one in there, and then into there. So then the long negative cable is going to go from this bottom battery here across and up. In order to do that, we've got to thread it through this little hole in the side of the door. But bear in mind that hole is also going to need 2 reds coming through and an earth wire. So there's quite a lot of cables to go through there. So we're just going to slide that through gently until the length is correct. So click that one in, and then just keep sliding this through, and then we'll pull that on the other side. So here on the second stack, we'll just pull the extra slack through, and then that is going to go into this battery negative here, like so. There's a little bit of slack, but not a lot, which is why I said to you earlier to space them 600 apart. There's just no way that the cables would reach. And the last little negative cable to then go from this battery to this one. We've got one really long battery cable. Now you can see the lengths in the instruction manual if you want to know exactly how long those are, but that one's going to go from the inverter all the way through to the top of the last battery. That top one there. Going to run it through the little hole in the door here. Like so. And up into the inverter. this one's here is going to be spare, so we're going to put a bung back in that one. And we've got one positive between those two, and then we've got a slightly longer one now from this bottom battery module to the bottom battery module on the other side. So that will go to this bottom one, and then the last one goes between these two modules here. Make sure they click. There we go. And then this long one between the two. There we go, and that is all the battery to battery cables in. So this little cable is the first comms cable that goes between the inverter and the first battery module. And the plug in the back of the inverter is a little bit hard to get to. You've got to just get your hand around the back there, unscrew the little cap, and then plug this in and just screw this back in so that it maintains a waterproof seal. So a little tip, the RJ45 needs to go like that, so the prong is facing out to the side. That way it will line up properly. It's hard to see that from behind. So that's screwed in there. So then you've got all these comms cables that go between the battery modules, and they just go from the bottom socket to the top socket, bottom socket to top socket, etc. There must be a long one that will go between the two bottom modules. That's part of the long cable kit. So that just plugs in there. And then again, you just screw the gland on so that it holds it into place. You don't want it pulling out and then losing communication between the batteries. So then lastly with the cables, we've got to run the earthing / bonding cables. So we undo these earth terminals here. It's really nice because they pre-made these off. Just put the screw through the lug there and then screw that back on. So once you've got all the battery earth cables linked, we've just got to pass this one through from this side to the other side. And this is the one that links the top battery to the inverter. So I'll be honest, we've still not found a perfect way to dress these cables as they go in between the batteries. What we've done is just put a couple of cable ties on them to hold them together neatly and just hold them up off the floor. However, you could always put some kind of cable sock around them, maybe some kind of cable wrap that will just hide them and make them blend in a little bit, or even maybe a little bit of trunking, but it is hard because they're quite thick. Right, so there's an Ethernet port in here, and that's what we're going to do here. We've got a network switch nearby. We're going to hardwire our Ethernet connection. Now you don't have to do that. It will work over Wi-Fi, but if you can hardwire Ethernet it, obviously it's going to be better than unreliable Wi-Fi. Yeah, so we'll just pop our A and B RS485 back in here. Then the Ethernet connection will just pop in there.
50 mil.
Yeah. So now that everything's wired up, there's a certain order in which we need to turn everything on, and I've got the instructions with me here to follow closely because, to be honest, it's not easy to remember the exact order. So if you're not sure, rather than risk damaging something and just winging it, just follow the instructions. So the first step is to turn on our AC isolator. Then we're going to turn on the backup / load isolation switch if backup is connected. So that's this one here. Then we're going to turn on the battery switch, which is this one. Then we're going to turn on all of the battery DC switches on the side of the battery modules. So these are here. You can see they're labeled DC switch, and there's a surge protector, a circuit breaker in there. We just turn that on one by one, turn all of them on. So those are all on now. Then we're going to press and hold the power button on any battery until the indicator light turns on. If you have more than one battery in the system, you only need to press the power button on one of them. Okay, so we'll do that on the main battery. There we go.
The others will turn on.
And then the others will talk to each other and turn on. There we go. We're going to close this now. That's important because that maintains the IP rating of the enclosure. This, by the way, is the PV isolator, so that's the DC isolator. If you've got solar panels connected directly into the MC4 inputs on the side here, you would turn that one on. That's the first step, but we've obviously skipped that because we don't have PV connected here. Then we're going to replace this cable cover. And to do that, just tighten up these thumb screws here. So I'm going to close all the lids on these DC switches on the batteries, just again to maintain the IP rating. However, we're not going to close these side doors just yet because we do have to scan the barcodes in order to register the warranty, and we'll do that right at the end once we know that the system's fully running and operational. So now that all the battery and inverter side is switched on, we're going to switch on the Libbi controller using our switch fuse connection unit. And now we need to go through the setup wizard. So we first need to select whether this is the first MyEnergi device installed or if it's an additional device. Here it's an additional device because we've already got a Zappi and an Eddy, but if you were only installing this as the first MyEnergi device, you would choose that first step. Now up and down is obviously what it is, menu is to go back, and plus is to select. Then secondly, we need to answer this question: is PV connected to the Libbi, connected elsewhere or not present? So when you've got PV connected directly into the Libbi, these are the inputs that you're going to use for your MC4 connectors. Now it's possible to connect 2 strings of DC cables to the Libbi. So this is PV1 plus and minus inputs, and this is PV2 plus and minus inputs. So if you've got 1 string, you would use these 2. If you've got 2 strings, you would use both sets. And each MPPT string can take 3,250 watts of panels, or 3.25 kilowatts, for a total across the 2 strings of 6.5 kilowatts maximum DC peak wattage. You've also got an inbuilt DC isolator switch here to turn the DC side on and off as needed. So obviously that's when, in this case, you would select PV is connected to the Libbi. But let's go back to the setup wizard at the previous site. In this case, PV is connected elsewhere, so we select that. Then we need to select if backup is connected to the Libbi or not present. It is, so we select connected to Libbi. Then we select the country of installation, which is Great Britain. Obviously there's other options like West Australia, Germany, Republic of Ireland, Northern Ireland, but we're here in Great Britain. And then we just review the settings. Libbi is slave, VHub is not enabled, Libbi PV not present, backup is connected, press plus to confirm, or menu to restart. So it says inverter must be powered up and connected to the controller, hold plus to continue. So we're going to hold plus. Unit will restart. Starting up. Please reboot the inverter before continuing. What? Hold plus to continue, okay. Right, okay, so the time and date are not appearing yet. Now, this is a little glitch that we've had on some installs. It should normally get the time and date from the hub in the Zappi, but we can just select. No, but we'll just set the date anyway. Later on, it will automatically sync the time and date. Yeah, it's a bit weird. There's a bit of a glitch that MyEnergi need to fix on the date thing. You can only select the first. So we're June 23. Okay. So now that the initial configuration is done, we need to do the CT configuration. To do that, we go into Menu, Device Settings, and then Advanced. The enter passcode for advanced is always 000, and then CT config. Now CT1 is always set to grid, but as we've already got a grid CT connected to the Zappi, we're going to turn that off in this particular case. So just set it as none. So now CT config, all of the CTs are set to none, which is correct. Now what we're going to do is pair the Libbi with the other devices on the system. So to pair the Libbi with other devices, you want to go to the menu, go to link devices info, you can see it's only by itself at the moment. Now if we go to device settings and then advanced and then linked devices, we can put it into pairing mode. So now this pairing mode is active on here. It's searching for a master. The Zappi is the master. So Lee's going to set the Zappi into pairing mode 2. And it's searching for slaves. And now it's found the Libbi. So all of the devices are now appearing on the Libbi, which means if we go to the main menu, we should see what's going on in the system. Yeah. So we're generating 7 kilowatts of solar at the moment. 3.7 are being exported to the grid, which means that the Libbi now is ramping up and starting to charge with that excess solar, and what we should see then is the amount that's being exported to the grid will go down. Now it's interesting because we've got a grid, an export limit on the solar edge inverter. We're going to have to take that off now that we're here, but that has ramped up the amount of solar because the load has gone up, so it won't export more than 3.6 kilowatts basically. But we'll remove the export limit on the solar edge inverter, and then you'll see that it'll constantly be generating 8 kilowatts. Now that we've got everything paired up between each other, we're going to check on the MyEnergi app to make sure that the Libbi's appearing there. And it has appeared. It says Libbi detected, and it gives you a little startup message. Congratulations, your new Libbi has been added. To enable Libbi to charge from the grid, please enter your energy tariff. So that is for if over winter you want to be able to charge the Libbi up overnight on the cheap electricity, you need to add your energy tariff details in, and then it will enable that. That's something the customer can do afterwards, but you might have to talk them through it and maybe get a copy of their energy bill to put in their tariff and their rates. So I'm just going to click OK on that, and it gives you the option to put in what your rate is, octopus, etc. We'll just ignore that for the moment. Now we're going back to the main menu, and we can see exactly what's happening. So at the moment, customer's generating 3.6 kilowatts. Sun's just gone behind the clouds a little bit. The Libbi is charging up at 4.5, and we're pulling a little bit from the grid. That's because it's doing a calibration charge, which it does as standard when it first gets going, just to make sure that all the batteries are balanced and synchronized. So it says here on the screen, calibration charge, and it will just charge at full pelt, basically, until all of the batteries are fully charged. It'll only do that once, and once that's done, it will just charge from excess solar or however you've set it up to charge. So we're just going to check through a few settings here and show you what's what. First of all, what I like to do on every device is just do a firmware update just to check. For example, we don't know if a new firmware has been released for Libbi since the controller was sent out. There we go. So we've updated the firmware on this, so that's all up to date now. If you go to link devices info, just a little thing, the capitals means the device that you're looking at right now. So that's just a little tip for you. If you're on the Zappi, then Zappi would be in capitals. What we need to do sometimes is in device settings, we need to go to internet, and we need to set Wi-Fi. So if you don't have a hardwired Ethernet connection, then you will need to set up the Wi-Fi, and you can just do that using Wi-Fi config and pair it up to the local Wi-Fi network. Other things that you need to think about are in the advanced menu, supply grid. You can set a device limit, so you can set a charge and discharge limit if you want to. So for example, charge limit 1 amp all the way up to 18 amps, 5 kilowatts, and then you can set a discharge limit as well. So we won't set these, but it's an option if you want to, that you can set those. The other thing is an export limit. Now, you have to get G99 approval to install a 5 kilowatt inverter to the grid, even if it's just a battery inverter, because technically you could force discharge the battery and export 5 kilowatts out to the grid. So some DNOs, or distribution network operators, will require an export limit to be set on the site. For example, here we've got an 8 kilowatt solar inverter, we've got a 5 kilowatt hybrid inverter for the battery here, we've got another 3.6 kilowatt inverter in the house as well. So total potential export at this site is like 16 kilowatts potential export here. But the DNO have not mandated an export limit. However, sometimes they might do. They might say to you, you've got to set a 5 kilowatt export limit. If you want to do that, you just set it here. So supply grid, export, and then you set your export limit. Again, it's in amps. and it can go pretty high because it's taking all of the devices into consideration. So it's basically going to measure how much power is going out to the grid from all of the devices put together, and if you go over that limit, it will ramp the Libbi down to stop exporting any more than that limit. Another thing you need to do when installing a Libbi is set a grid limit to protect the main fuse. That's all about import, so how much power you're pulling into the property. You don't want all of the MyEnergi devices to be pulling power at the same time, as well as running loads of stuff in the house and below the main fuse. So like here, for example, the Zappi could be pulling 7 kilowatts, the Libbi could be pulling 5. That's already 12 kilowatts. Plus maybe they're running a heat pump and an electric shower and stuff in the house. Suddenly 100 amp main fuse goes pop. So what you can do is in the master device, which in this case is the Zappi, you go to other settings, advanced, then you go to supply grid, network, and then grid limit, and you want to set that as the same as the main fuse. So here we have a grid limit of 100 amps already set, which is perfect. Now, one of the final but very important steps is your product registration in order to register the warranty. That can only be done as an improved installer who has access to the MyEnergi installer portal. So what we do is we go to installer.myenergi.com, we log in using our installer credentials, and then we scan the barcodes on all the devices to register them to show MyEnergi that they've been installed on this date by us, and therefore they have a record for warranty, so that if there are any issues, they know when it was installed, what the products were and who installed them, and they can arrange for warranty replacement. So once we've got all the serial numbers in, what I like to do is just take a screenshot and send it to the office so that we've got a record of all the serial numbers on our system that we've installed and submitted, as well as them going through to MyEnergi. Then we click submit and they get sent through to MyEnergi. Obviously, these are fake serial numbers because we can't show personally identifiable information, but you get the point. Now, another important step is the customer handover. If the customer's already got MyEnergi devices like they have here, they'll already have the MyEnergi app set up, and the new device will just appear on their MyEnergi app. Dead easy. If this is the first MyEnergi device that the customer is having installed, then they will need to register for an account with MyEnergi for the app, add the serial number and the registration code into the app, then that will find the products and then they will appear in their app. One thing that I like to get customers to do as well is get them to share their location with me. So they just put in my email address and share, and then I can see what they can see on the app. I like to monitor it for a week or so afterwards just to make sure that everything is talking to each other and it all looks good, looks to be working how it should, all the CTs are the right way round, etc. That means it's just a nice touch for customers to make sure you're keeping an eye on their system, and then obviously they can stop sharing with you at any moment that they want to. Now, part of the setup as well is what's called commissioning. This is in the installation guide. You need to check to make sure all the batteries are communicating with each other. That's the first step. In order to do that, we go to main menu, readings, and then what we're going to do is go to page 5 of 6 and just make sure that the battery size matches the amount of batteries that you've fitted. So in this case, 20,400 watt hours, so 20 kilowatt hours, inverter rating 5,000. That is correct. If the battery size isn't showing all the modules, maybe if it was showing only 15 kilowatt hours or something, that means one of the modules isn't talking to the others, and we need to check the communications cables. Now, another thing we need to check is to make sure the time and date are correct. This is essential for time of use charge and discharge. So that is correct, and that means that if the customer does try to charge it overnight on the cheap electricity, that it is going to charge up at the right time. So another thing you need to do is just check that the grid power CT is reading as expected, whether that be importing or exporting. Sometimes an easy little tip to do is get the customer to turn the kettle on and just make sure that you're importing 3 kilowatts or whatever it is for the kettle from the grid. If when you turn the kettle on it shows that you're exporting power out to the grid, then you know that the grid CT is the wrong way round. You can view all the CT readings in the main menu in readings. You can see how much power is being imported and how much current is being used by the charger at the moment, the state of charge on the battery. You can see the voltage, and it's got a max and min on there. You can see the frequency, and then the grid current, so how much current is being used from the grid and what that is in watts. Generation, so this is from the generation CT. You can see we're generating 3.5 kilowatts at the moment. Consumption, that's how much is being used by the house, and this is how much we're importing. And then diverting and output. So that is how much power is being diverted into the batteries at the moment. Now, if you have a separate generation CT like we have here, you need to check to make sure that the sunshine is generating on the little screen on the Libbi. That shows that the generation CT is working and that it's pointing in the right direction. We need to check to make sure it's connected to the internet properly as well. So to do that, we go into the menu, we go into device settings, internet, and then internet info. We can see that it's got an IP address, so that's all good. Now, there is a setting in these now that they will automatically update from the cloud. So in internet info, it's got a cloud connection, and that ensures that it will automatically get over the firmware updates going forward. That is an option that can be turned off if the customer wants. So once you check that all the safety limits have been set, like the grid limit and the export limit if needed, if you've got backup power, you need to check that the backup power is working correctly. So in this case, our backup circuit breaker is on. We've got these two backup sockets. We can turn them on. We can see that they're both working okay right now. Now what we want to do is check to make sure our backup RCD tests out properly, which it does. We'll do an earth loop impedance test on those sockets in a minute and do an RCD test. But the main thing we want to know is, does the backup power kick in okay when we turn off the isolator for the Libbi? So let's have a go. There we go. Still powered on, even though the Libbi is powered off. So that's exactly what we need. Now the last but very important step is the customer handover, and that's where you want to show the customer what you've installed, how it all works, explain it to them in layman's terms that they'll understand. Maybe a good idea to hand over the user operating instructions. Now I've printed out a copy for the customer. Obviously if you want to save paper and trees, you can send them a digital copy. That's up to you. But it's really important that the customer feels confident that they know what it does, how it works, and especially show them MyEnergi App. Things like prioritizing devices by sliding up and down so that they can choose which device gets charged up first from the excess solar is a really important little tip. Also showing them what all the graphs mean and stuff so they can get to grips with their data is a really nice touch too. That customer handover is a very important step in the process. There's a couple of finishing touches that are vitally important. One of my favorite ones is this, peeling those lovely little bits of foil off. Now, of course, it's really important that you test and inspect all the AC side of things. So we've tested our various test readings for all of these AC devices that we've put in. The AC isolator, we need to issue an electrical installation certificate because it's a new circuit that we've installed. We also need to issue a building regulations certificate to the customer. That'll all get done and sent over to the customer digitally afterwards. There's also some stickers that we need to put in. So we put a battery warning sticker in there and a dual supply warning sticker. Those two are really important parts of the installation that you need to put in. Also, if you are connecting PV to this, you will need to have a generation meter like this, which basically shows how much power is being generated and put back into the system. And my little finishing touch that I like to install is an Artisan Electrics sticker. So I'm testing the backup circuit here. The Libbi isolator is off, as you can see, but we've got 230 volts. And what I'm going to do is do an auto RCD test and just make sure that the RCD operates still. So quick. There we go. So our RCD tripped 126 milliseconds and 25.1, so that's absolutely perfect. Out of interest as well, we'll do an earth loop impedance test. 5.85 ohms, which is absolutely fine because the circuit's protected by an RCD. So there we are, a beautiful solar array feeding into a beautiful MyEnergi Libbi battery, making this home reliant much less on the grid and much more on their own generated solar energy. I hope you've enjoyed this video today. Hopefully it's been helpful for some of you guys who are trying to learn how to install Libbis, and maybe you're a customer who is just curious about the whole process. Well, if you are, and if you'd love us to install your Libbi for you, please get in touch. There'll be a link in the description below. But either way, thanks for watching today, and we'll see you on the next one.